Okay, alkene and alkynes. Now, alkene is double bound, alkyne is triple bound. Just see the namings. Again, you have that. Make sure when you have double bond in the longest chain, you need to include your double bond. And you start counting from the end that give you the lowest number for double bond. I need to count from here, 1, 2, 3, 4. I don't count from there because it will give me a higher number for my double bond. Then 4 is but, right? But, you have to add ene because this is alkene, this is double bond. On third, we have methane. There's going to be 3 methane, butene. I'm just going to check them. 3 methyl 1 butene. Oh, I forgot to tell you, you have to specify the number of the double bond. On a second carbon, you have double bond, right? You need to say 1 butene, and then on third carbon, you have methyl. Any question? Now, draw the structures for 2-methyl-1,3 pentadiene. See, said diene means you have a 2 double bond. Pent means you have 5 carbon. So you put 5 carbon, as I said, is pent. On first carbon and a third carbon, you have double bond. There's on a first carbon here, and third carbon, you have double bond. 2 methyl means you have 1 carbon attached to second here. And then you can put your hydrogens around. Okay. This is, write the IUPAC name. Since we have a double bond, it's alkene, but it's in cyclo, right? You have 6 carbon around. There's gonna be cyclohexene, Y-A-E-N-E, because of course you have double bonds, alkene. Then always you put the first carbon to that is start with double bond. Then if you start here 1, 2, 3, on a third carbon you have methyl. It's gonna be the IUPAC name gonna be 3-methyl cyclohexene. Any question? Okay. Now draw the structural diagram for 3,3 dimethyl 1-butene. Butene, again, you put 4 carbon, and on the first carbon you have triple bond. On the third carbon you put 2-methyl, because this is like a 2-methyl. Di is 2. And here is the diagram of that. Write the IUPAC name. You have to choose your longest chain. Also, make sure your double bonds, all of your double bonds need to be included in the main chain. So it's 1 on the first one, and on the third one you have double bond. And 1, 2, 3, 4, 5, 6. It's going to be hexadiene, because you have a 2 double bond, you have to put di here. The first carbon and third carbon, you have that. And if you go back, this is isopropyl. On a third carbon, the isopropyl is attached. Okay, so these are the questions I'm asking you to. This is page, what is that? Page 19. Question 5 and question 6. I'm going to teach a little bit this one as well. Aromatic hydrocarbons. See, when you have 6, this is benzene, right? When you have a circle in the middle, means this is a benzene ring. On the first carbon, second carbon, you have ethyl. It's going to be 1, 2 diethyl benzene. Here you have on the first carbon, third carbon, so it's 1, 3 diethyl benzene. And here is on first now 4 carbon, you have it, that is 1,4-diethylbenzene. So here, yeah, this is the benzene ring. So this is gonna be what? Methyl benzene. And now if you want to attach the second methyl, it could be on a second carbon, third carbon, or fourth carbon. We call all of them isomers because they have the same number of carbon and hydrogen. True, but different configurations. Okay, so is there any question here? No. Okay, I want you to name, so this is page 21, question number 7 and 8, you do. Now, physical properties of hydrocarbons. See, this is all methane. As they become bigger and bigger, the boiling point is increasing, right? Because as they getting larger and larger, the surface contact between the molecule gonna increase. You have more electron, more proton, means van der Waals force between the two molecules increase. This is harder, but getting harder and harder. If it's getting bigger, it means harder and harder to take them away. It means the boiling point gonna increase as your molecule getting larger and larger. So questions you do, this is page 22. Question number 2 only. 2, 3. Yeah, 2 and 3. Okay.